Elon Musk recently unveiled the Tesla Optimus Gen 3, a humanoid robot that's capturing the attention of the tech world. Unlike any ordinary machine, this robot doesn't just walk or perform simple movements, but acts as an intelligent, fast, and highly capable assistant with accelerated learning abilities. The idea of a robot learning 1,000 new skills a day, using only a Wi-Fi connection and YouTube videos as a source of knowledge, is enough to impress any expert. With a sleek design, advanced artificial intelligence, and a price tag under $20,000, Optimus promises to transform everything from domestic life to entire industrial sectors. What once seemed like science fiction is now dangerously close to reality. Optimus is no longer just a distant concept in development. It's an affordable, rapidly evolving machine ready to perform complex tasks. The vision is clear: to offer not just support, but true independence for the elderly, domestic assistants, and even educational functions. However, this technological revolution also raises profound questions. Are we truly prepared to live with machines that may eventually surpass us in efficiency and knowledge? The mere mention of humanoid robots provokes diverse reactions. For some, it's a glimpse of a future where dangerous or repetitive tasks will be completely automated. For others, it's a cause for concern, sparking fears of job losses and dystopian scenarios worthy of science fiction films. In the popular imagination, humanoid robots still carry images of fragility, clumsy movements, and high cost. However, the arrival of the Optimus Gen 3 challenges this perception, offering a functional, robust, and competitively priced device. Musk has already stated that the final mass production cost should be between $20,000 and $30,000, making the robot more affordable than a new car. This opens up unprecedented possibilities for families, businesses, and institutions. The elderly care market, for example, could be revolutionized with an assistant capable of performing everyday tasks, maintaining safety, and providing constant, reliable companionship. Relative low cost and ease of production are key elements of this strategy. What's truly impressive, however, is Optimus Gen 3's learning capabilities. Unlike conventional robots, which rely on manual programming or remote control, this model learns by watching videos and simulating actions in virtual environments. Just as a person uses tutorials to learn a new recipe, Optimus observes the content, practices billions of times in simulation, and then performs the task accurately in the real world. This represents a huge leap forward in terms of efficiency and versatility. In recent demonstrations, the robot was seen performing common household tasks: sweeping, vacuuming, cooking simple meals, using microwaves, collecting trash, and cleaning surfaces. It was also tested in industrial settings, handling parts on production lines. The great advantage lies in the simplicity of the command. A clear voice instruction is enough for the robot to understand and execute the task from start to finish, without the need for complex programming or additional scripts. Another notable innovation is bimanual coordination. Previous versions of Optimus predominantly used one hand for basic operations. Now, with fluid, synchronized movements, it can perform complex human actions, such as handling tools or carrying objects, with greater precision. This ability is supported by hardware developed by Tesla itself, with each hand offering 22 degrees of freedom, ensuring delicate manipulation that adapts to different contexts. Optimus's learning isn't limited to the individual level. Thanks to a centralized intelligence system, whenever a robot acquires a new skill, that information is immediately shared with all the others. This means that the evolution of a single unit translates into progress for the entire fleet, exponentially accelerating the collective capacity of the robot network. This model is inspired by the way Tesla trains its self-driving cars, accumulating data from millions of miles driven. Tesla also applies its expertise in areas such as electric motors, batteries, power electronics, and structural design to the development of Optimus. The company's experience in large-scale manufacturing is a decisive differentiator, as most existing humanoid robots never make it beyond the prototype or limited production phase. With mass production capabilities, Optimus moves from an experimental product to a real, scalable solution. In industrial settings, this shared learning capability translates into immense productivity gains. Imagine a production line where, by teaching one unit to assemble a part, all the others learn instantly. In a short time, the company would have a catalog of millions of mastered tasks, ready to be executed in different sectors. In the home environment, the impact would be equally transformative, with robots capable of adapting their performance to the specific needs of each user. And it's not just about replicating movements. Tesla's learning model includes large-scale error correction, ensuring that, in the end, the task is performed with near-perfect accuracy. This is especially relevant in sensitive areas such as healthcare, logistics, or high-risk operations, where consistency and safety are crucial. Therefore, Musk claims that Optimus could become the most important product in Tesla's history, surpassing even electric cars. The robot was designed for durability. While many commercial equipment has a lifespan of between 5 and 10 years, Optimus is designed to operate for up to 24 years in real-world conditions without major overhauls. This longevity is the result of the choice of advanced materials, such as aircraft-grade aluminum alloys and carbon fiber-reinforced polymers, ensuring strength without compromising agility. Vulnerable points, such as joints and spine, receive special engineering attention. The internal mechanisms are also built to withstand the test of time. The joints undergo testing for up to 1.5 million complete cycles, simulating decades of use. The gears are lubricated with high-quality synthetic compounds, and the motors have intelligent systems to prevent overheating. Power is provided by Tesla's 4680 batteries, known for their durability and stable performance over the years. Energy management includes adaptive algorithms that prevent frequent overcharging or deep discharging, extending the lifespan of the cells. The robot itself monitors component wear in real time and automatically adjusts its behavior to prevent damage. If a joint is under excessive stress, the system redistributes the load to preserve the integrity of the structure. This self-preservation capability is one of the design's most impressive features. Furthermore, Optimus was developed with a modular architecture, allowing for the rapid replacement of parts such as motors, sensors, and actuators without the need to disassemble the entire system. This reduces maintenance costs and keeps the robot operational for longer. It also undergoes extreme testing, including temperature variations from 25 degrees C to 50 degrees C, drops, vibrations, and exposure to dust, ensuring operation even in harsh environments. This combination of physical endurance, accelerated learning, and knowledge-sharing places Optimus in a unique position in the market. Until now, most humanoid robots were limited to demonstrations at trade shows and laboratories, but Tesla is ready to integrate them into the daily lives of people and businesses. This paradigm shift could completely transform entire industries, from manufacturing to service provision. At an event originally intended to showcase Tesla's Cybercab, the autonomous taxi, the presence of 50 functional Optimus Gen 3 units ended up stealing the show. Visitors were able to interact directly with the robots, witnessing their abilities up close. It was a memorable moment as, for many people, it was the first time a humanoid seemed truly useful, trustworthy, and close to being integrated into everyday life. These units demonstrated not only dexterity in household tasks, but also the ability to perform more specialized functions, such as inspecting deliveries, serving drinks, and even efficiently folding clothes. The naturalness of their movements and quick adaptation to new commands reinforced the feeling that Optimus is no longer just a prototype, but a commercial product in advanced development. The target price of $20,000, combined with the estimated production cost of around $10,000 per unit, creates an extremely competitive landscape. This is made possible by the use of components shared with Tesla vehicles, such as the 4680 batteries and some electronic modules. This standardization not only reduces costs, but also simplifies maintenance and speeds up production. Unlike many competitors, which rely on proprietary and difficult-to-manufacture parts, Tesla is betting on an integrated ecosystem in which robots and vehicles share core technologies. This model ensures scalability and makes it possible to deploy thousands or even millions of Optimus units in the coming years. It's an approach reminiscent of the revolution sparked by the company's electric cars. Large-scale production capacity also means that software evolution will be much faster. With more robots operating in the real world, more data will be collected and processed, feeding the central artificial intelligence network. This accelerates the learning curve and increases the variety of skills each unit can perform, whether in home kitchens, assembly lines, or hospital corridors. Integrating Optimus into the healthcare sector, for example, could open up new possibilities. With its precision and continuous learning capabilities, the robot could assist nurses with tasks such as transporting medications, monitoring patients, and sanitizing equipment. This would free up human professionals for roles that require clinical judgment, empathy, and complex decision-making, increasing the efficiency of medical services. In the logistics sector, the presence of humanoids like Optimus can also revolutionize workflow. Imagine distribution centers where robots roam freely through the aisles, sorting and packing products while communicating with each other and with management systems to optimize routes and delivery times. This complete automation isn't just about convenience, it's also about reducing costs and minimizing errors. In education, there's a vast field of applications. An Optimus could function as a personal tutor, helping children learn languages, math, or programming in an interactive and personalized way. With instant access to databases and adaptive teaching methods, each robot could adjust content and pace according to the student's profile, making learning more efficient and motivating. Still, the debate over the impact on the job market is inevitable. Replacing human roles with machines generates resistance and concern, especially in sectors where automation could advance rapidly. Musk and Tesla argue that, as in other technological revolutions, new types of jobs will emerge to meet the opportunities created by these robots, at least partially offsetting the loss of traditional positions. From an ethical perspective, important questions also arise. How safe is it to allow highly autonomous machines to operate in human environments without constant supervision? How can programming or sensor failures be prevented from causing accidents? Tesla argues that its experience with autonomous vehicles serves as a foundation for creating redundant systems and robust safety protocols, minimizing risks. The company also emphasizes the importance of transparency in its programming and update processes. As with the brand's cars, Optimus will receive continuous software improvements, meaning the version purchased today could become much more capable in the coming years. This constant update model increases the product's relevance and increases the user's return on investment. The shared network factor further enhances this effect. Whenever a robot learns a new skill or optimizes a procedure, this knowledge is instantly transmitted to all the others, creating a cycle of collective evolution. It's as if each unit were part of a global brain, learning from the combined experience of the entire fleet. However, for this revolution to be fully accepted, the public needs to see Optimus as an ally, not a threat. Tesla's strategy appears to focus on humanizing the relationship between people and robots, offering more natural interactions and demonstrating practical utility in everyday life. Showing the robot cooking, cleaning, and assisting the elderly helps build empathy and break down psychological barriers. The cultural impact of this coexistence cannot be ignored either. We live in a time when artificial intelligence is already influencing areas such as art, writing, and strategic decision-making. The introduction of physically present robots into homes and workplaces is an even more tangible step in human-machine integration, and its acceptance will depend on technological and social factors. Musk's vision is clear. Optimus is just the tip of the iceberg of a future where humanoid robots will be as common as smartphones. This will require not only continuous hardware and software improvements, but also the creation of policies and frameworks that ensure the safe and beneficial use of this technology for society as a whole.